conference on quantum physics, brain function in modern science and Buddhist philosophy, organized by Tibet House, the culture center of His Holiness the Dalai Lama. To begin with, may I please request our Honorable Chief Guest, Professor P. Goswamiji, Director, National Institute of Science, Technology and Development Studies, New Delhi, and Professor N. Mukunda, Professor C.C. Roy, and Venerable Kishitoji Damdila, Director, Tibet House, to light the lamp and inaugurate the conference.
I see how to do it. That is true. I also so I just press this one.
Yes.
Maybe that's not enough oil in the wheel.
Yeah. No, it's not. Yeah.
Thank you. And now may I request our delegates to take their respective seats on the dais. Now may I request Venerable Kishitoji Damdila, Director, Tibet House, to honor our respected delegates with mementos. Professor P. Goswamiji. Professor N. Mukunda ji. Professor C.C. Roy ji. Thank you, Gishla. Before we begin with the actual session, I would like to give you a quick overview of Tibet House. Tibet House was founded in 1965 by His Holiness the Dalai Lama to preserve and disseminate the unique cultural heritage of Tibet and to provide a center for Tibetan and Buddhist studies. Tibet House has a museum of valuable Tibetan art and artifacts, as well as library with over 5,000 volumes of manuscripts and books, a conference hall where weekly Buddhist philosophy classes and monthly lectures are held. Tibet House offers incentives and resources for research and translation projects and publishes important texts. It hosts lectures, conferences, exhibitions, film screenings, and festivals. These programs mainly focus on Indian and Tibetan Buddhist history, religion, philosophy, art, literature, and culture, and bear witness to the vital and evolving heritage of the Tibetan people. Tibet House also offers a unique 4-year master's course in Nalanda Buddhist philosophy, where there are over 300 participants from 42 different countries, and Nalanda Diploma course, which is a 1-year course in which there are over 600 students from 39 different countries. So without much ado, now may I request our director, Venerable Geshe Tuji Damdila, to give a keynote address from the Buddhist perspective. Thank you.
Good morning, everyone of you. Respected Chief Guest, Dr. P. Goswamiji, Director of the NISATS, and our keynote address, the presenter, Professor N. Mukundaji from the Indian Institute of Science, and the convener for this program, Professor Cecil Raji from NIAS, National Institute of Advanced Studies, and venerable monks, and all the speakers, presenters, chairpersons, and all the participants. It's a great joy for me to be here. Tibet House, as you already know, that we've been organizing this kind of program, particularly comparative studies in modern physics, quantum physics, relativity theory, versus Buddhist philosophy of the shunyata, emptiness, and dependent origination, and likewise neuroscience, the contemporary neuroscience concepts, and then in line with the Buddhist psychology. And at one point, the Tibet was also invited the many presenters from different traditions, from the Hindu tradition, Christian tradition, Islamic tradition, Jainism, and so forth, to speak on their view of the perception, their view of the epistemology. This is one area which Tibet House focuses so much on. So today, it is the theme is quite heavy. Quantum physics, brain function in modern science and Buddhist philosophy. And we see that I remember a few years ago, at the request of the Vice Chancellor then of Jawaharlal University, they organized a program on a conference on quantum physics and the Buddhist philosophy of shunyata, emptiness, according to our Nagarjuna. So that was presided over by His Holiness Dalai Lama, and the then Vice Chancellor of the Jawaharlal University. And both sides, presenters were there, quantum physicists, and then Buddhist scholars are speaking on the same theme. So today is it's going to be a very exciting day for all of us here, particularly looking at what the quantum physics, quantum is, and how the brain works, how the mind works, from the point of the modern science and from the Buddhist philosophy and psychology. So this is more comparative studies being organized here. So in this connection, what I'd like to share with you here is that, say, the world, the universe, which we live in, this universe, since like, I think, 0.8 million years ago, the Homo sapiens first originated on this earth. The human thoughts were in the constant evolution, and it became more and more complicated. And then eventually, about like 300 years ago, the Newtonian physics became very popular, and it was as though like the dominating knowledge of the world. And then over time, there was the paradigm shift from Newtonian physics to quantum physics, relativity theory, and seeing that from there, come to realize that what was presented by Newtonian physics is possible. There's a tremendous shift there in terms of the paradigm of physics. So there, what were we exploring? If we keep in mind, if we explore, if we see what we are trying to explore, we see that particularly with the physics, we're exploring that's what constitutes the reality there, out there, ontological reality. What was once believed by Newtonian physics, say the space as relative, and the time as static, as constant or static, and then the relativity theory, Einstein, with the advent of the general theory of relativity and the special theory of relativity, with the relativity of not only space, the relativity of time also was being presented. So this is the evolution of the human knowledge, this amazing thing. So meanwhile, say in the West, there was the other side, which was like the background, the backbone of the modern physics. Initially, for example, the great thinkers like Socrates, Plato, Aristotle, and so forth, they came up with lots of questions, and these questions eventually, the responses to these questions became more and more solidified, crystallized, and now today it came to be physics, modern physics, quantum physics, relativity theory, and so forth. So parallel to that, in Asia, and particularly in India, there was a tremendous the discussion, debates going on to explore what ontological reality is. So this was the constant evolution happening in India as well. So from this, what we can say is that a mind sees the world. What the world is, we decided on the basis of our thinking, what we think. And the thinking, depending on how subtle, how profound, how complicated, how intricate your thinking, the thought process are, to that extent, then you determine that, okay, this is the ontological reality. What was presented before cannot be held as the reality no more. So now we see that there's a subtle reality there. So there's all decided by the mind. So there we see that there's the interaction between the object to be explored and the subject, your mind. So pertaining to the object, that's what constitutes the reality out there. What's really there, what we are seeing, is that the reality? What we see, is that what represents reality? This question. So there, the study of the ontology or the ontological reality, that became very important. Then the next part is who decides that this is ontological reality? Who decides? Our mind decides. So the study of the mind plays a very important role. So pertaining to that, there is the psychology, and then later on, within like 100 years, we see the incredible development in neuroscience. So neuroscience and the psychology, Western psychology, Eastern psychology, they are to tell us as to what constitutes the subjective reality. The mind, the subject, is the agent which is found to decide what ontological reality is. And then number 3 is the interaction between the two. Interaction between the two, the subject, the object, in terms of the ontological reality, and the subject, the psychology that we study, and the neuroscience. So there, the interaction. So on that basis, we have the cognitive science and epistemology, which play a very important role. So now, from that point of view, let's say, of course, there are many, the physicists as well as we have neuroscientists here, we have Western psychologists here, we have Buddhist scholars here. So they're going to make the presentations from their own areas. And then the audience, we can see how much we can see the complementarity of these traditions and how to say, for example, the Buddhist scholars say in what way the quantum physics, the neuroscience, they make the presentation to see to the ontological reality, the presentation, particularly the pertaining to the modality of how the views are presented. And then for the scientists as well, particularly for example, say the neuroscientists and the neuroscientists, I would say that Buddhist psychology has a tremendous thing to offer. Although the neuroscience is extremely rigorous discipline, incredibly rigorous discipline, and Buddhist psychology, in terms of the rigor, I'll say the way to be presented as so empirically there. So that may not be there, but the rigor is there in terms of going to the incredible nuance, the nuances of the workings of the mind, and to the extent that something which is so empirical, not to be taken blindly, but very empirical, yet something which the neuroscience today is yet to be developed to that extent of explaining such phenomena of subtle workings of the mind. So I think there's the mutuality in terms of the taking and learning from each other. So that would be greatly helpful for all of us. And then speak a little bit about, the ontological reality from the Buddhist point of view. We see that in Buddhism there's a concept which is known as emptiness. And the parallel to that, there's a concept known as dependent origination. Studying quantum physics, for example, I remember when I was in class 12 meaning before I joined the Institute of Buddhist Dialectics, before I became a monk, the class 12, CBSE class 12, the first time we were introduced to quantum physics. And the class 12 board exam, most of you already know the system, CBSE board exam, and we were supposed to be prepared for the board exam, and I was more engrossed into inquiring about quantum physics. And then my teacher eventually, what he told me is that, Dorji, you don't have to worry about quantum physics. This will not come in a paper. What he said was that this is something just for you to be introduced to, and then when you go to college, that is what you are going to study in more detail, just to give you a glimpse of what quantum physics is. For that matter, that is introduced, not that it's coming in the exam paper. So, but my mind was still not happy with what my teacher said. I was constantly inquiring. This topic is extremely interesting. Okay, so now we see that I'm very fortunate from that point of view, being a little bit exposed to quantum physics, relativity theory since my high school time, and then later on, being exposed to the Buddhist, very complicated Buddhist philosophy of shunya and emptiness. So there, I see that at times I see a great parallel. So of course there are many scholars here, the quantum physicists as well as the scholars here, the Keshivas here, and then we have Professor Cicero there. Of course he is of course a great physicist and a very dear friend of mine, and the Dr. Malaji, very close to, very dear to me since many years ago, 2005. And you may be wondering how this conference came to be. So it all started from 2005. 2005, when Professor Cicero-ji here, Professor Cicero-ji, he just sent a mail to His Holiness the Dalai Lama. But he thought that His Holiness is going to give him a response right here. So asking questions about, some complications, more the philosophy of science. And then of course His Holiness has millions and millions of people, and the mails coming to him. So one of the secretaries of His Holiness directed his question, directed his email to me. And it was my job. So then we became friends because of that question. Okay, so it has been a long journey together, about maybe now 12 years. 12 years. And it is through this that I really admire the scholarly qualities, scholastic qualities, and his inquiry into reality, and his inquisitiveness to learn more, the openness to all forms of knowledge. So that is something which is very inspiring. So from there, my journey also became a little rigorous, pertaining to physics as well as Buddhist philosophy. So the quantum physics, which talk about the randomness, which talk about the uncertainty principle, which talk about the quantum vacuum, which we talk about the quantum entanglement and so forth, we see that every time we study any part of this quantum physics, we see that there's a tremendous, the correlation with the Buddhist philosophy. It's an amazing thing. So whereas in Buddhist philosophy, we see that the concept what would be somewhat parallel to quantum physics, which is how things come to being through pure mental imputation, the pure, what quantum physicists would say as observer, by the part of the observer. Independent of the observer, observe makes no sense. So this is exactly what is said here in the Buddhist philosophy, that everything that we experience, that we see, that we hear, whatever, that simply comes into being by the power of your mind, through the imputation of the mind. So that's great relevance to this concept. At the same time, what I learned of relativity theory. So in Buddhist philosophy, there is the same terminology. The mutuality of relativity. Mutuality of relativity. How the subject comes into being by depends on the object, and the object comes into being by depends on the subject, and how everything comes into being only in relative terms. Nothing really exists there as absolute. So this is something which really struck me with so much awe. And then interestingly in physics today, people are looking for confluence in the two traditions, quantum physics and relativity theory. Otherwise, back like 50 years ago, 50 years ago, 60 years ago, while quantum physics explains the micro world, relativity theory explains the macro world. And so these two, like 50 years ago, these two are not compatible. These two are not seen as compatible. And interestingly, in Buddhist philosophy, what is parallel to quantum physics, the concept of the mere imputation by the thought, by the mind, by the subject, and then the relativity theory, these two are seen as compatible. And interestingly, in Heart Sutra, the form is empty, empty is the form. Form is not other than emptiness, empty is not other than form. From there, you will see that from Buddhist philosophy point of view, the macro world and the macro world, macro and the macro. So these two are seen in the light of what is known as the two truths, conventional truth and the ultimate truth. So what determines the two truths? What determines the two truths? One which is the visible reality, and the other which is the subtle reality behind that. So the subtle reality behind that is seen as the ultimate truth, and the visible reality that we see, that we experience, is known as the conventional truth. So there's no discordancy between the two. These two are seen as totally in harmony, provided that one understands the reality that these two are presented. These two are the same realities of the same object. These were two realities of the same object. So that is where the macro world and the macro world are being merged. So how these two merge is with consideration, or with understanding that things exist only with reference to, only with the subjective mind as the frame of reference. But the subjective mind that we employ is known as ultimate analysis, that what you see is the macro world of the reality, which is ultimate truth. Whereas when you subject the frame of mind in the form of conventional analysis as a frame of reference. Then we see that what we observe is going to be the conventional truth. So both are seen on the same object. So this is how the two things are merged together. And as long as we don't consider the frame of reference, the subjective mind into consideration, then trying to look for the compatibility of the two truths is something beyond the feasibility. So this is a little bit about, of course, the Buddhist scholars here, the conferences here. So let us see where the two can potentially meet, where the two potentially diverge. So this is what I think we need to there will be a great platform for us. Otherwise, such conferences of the hardcore physics and the Buddhist philosophy, and that too, a very refined understanding of Buddhist philosophy. There are so many philosophers who may not necessarily be very refined philosophers. So we are very happy that there are very refined philosophers here, as well as very refined quantum physicists. So, and then we have the psychologists, we have the neuroscientists here to present how the mind works and how the brain works, and that in correlation with the ontological reality. Okay, so thank you so much, and particularly from the presenters, the chief guest of honor, and all the presenters. It's such a great joy for us to really convene such a conference. It's very difficult because we are not getting the proper the speakers, presenters, and perhaps, say, if you look in the world, we see that such conferences, the meeting of the different traditions of high level is very rare. It's all because that the people who are, say, that level and ready to be a part of the program is much less. Okay, thank you, one and all. Thank you so much.
Thank you, Kishila. Now may I request Professor C.C. Roy, our conference convener, to address the gathering.
Good morning, everybody. Respected chief guest, Director, Tibet House, Keshila, and Professor N. Mukunda, the keynote speaker from the scientific perspective, and my colleagues, learned colleagues and friends. In the very beginning, you might ask me, by training and by profession, I am a theoretical physicist. So you might ask, or people might ask, the justification for me being here in such conference where So people will ask me, what is the justification being a theoretical physicist to arrange such a conference and give a talk here, because I'm being paid for my work in theoretical physics. On the one hand, maybe I have a hobby, I might have a hobby studying traditional Indian philosophy like Buddhist philosophy or Vedantic philosophy. So in this context, I'm tempted to quote the famous statement by one of the fathers of quantum theory, Heisenberg. Once he told, I did feel a little uneasy, particularly since those lectures arose from my official duty as a professor of theoretical physics. Need to explain, though I was myself not so thoroughly convinced of it, that in passing the time with narratives about Greek thinkers and with comments on their views, I was not just following a recently acquired hobby of mine. It was justified by the hope of some gain in understanding modern science, and thus inter alia also modern physics. So my colleagues here who are hardcore quantum physicists and neuroscientists and psychologists, they might ask that why we will be here studying this, giving lectures and connecting with a philosophy which is more than 2005 years old, that is Buddhist philosophy. Whether we can get really kind of insights so that it will be useful for professions as well as understanding. And this is very, very crucial question we should try to think of. Otherwise, we won't get really a fruitful discussions or fruitful collaborations for future scientists and philosophers too. So, what Heisenberg emphasized, that endeavors of both scientists and metaphysicians to secure insights refer to the same object, that is man and the world. And it's important to note that methodologies followed by science and those followed by ancients are radically different. Due to technological developments, the scientists started to use more and more sophisticated instruments to probe the matter from larger scale to smaller scale. And the happenings in more and more minute intervals of time. I mean, starting from galaxy, quasars, stars, sun, coming to everyday object, go beyond that to micro objects like electrons, protons, neutrons, quarks, or Higgs bosons. So it is the scale of spatial as well as temporal scale. And it is essentially a reductionist approach trying to understand the whole cosmos, considering the smallest entities as building blocks of the nature. But the question is, why the quest? Is it the innate nature of the human being? Why people are asking to go to further and further on? And same thing happens to philosophy also. Why they are looking for different layers of reality. So it may be possible that Buddhahood exists in every being. So they are questioning, they are asking, and coming to more and more final layers of reality. And finally, Nirvana. And there are some things which is very important in science, both in quantum physics as well as in other science. We say that laws of nature, like, why apples falls to the earth, towards earth, because of the gravitation. So gravitation is a fundamental law of nature. Similarly, electromagnetism, there are many, many fundamental laws of nature. And this is very important to note that when the universe being manifested according to modern cosmology from a quantum vacuum because of the fluctuations, whether the laws of nature were there or it is being created after the manifestation of the universe. So laws of nature means kind of constraints. So why there are constraints in nature? Again, like if you see the law of conservation, like conservation of energy, and it is assumed that it is valid for throughout the whole universe. But again, what is the philosophy of this conservation law? The famous physicist Richard Feynman in USA is one of the greatest minds in 20th century. He told that conservation law is nothing but kind of constraints in nature. So why there is constraints in nature? How can you understand from Buddhist perspective? Because if you look at the Nagarjuna philosophy, they say pratikta samutpada, or dependent originations, or dependent arising. So if there are constraints in nature, then how do you explain these constants of nature, constant in nature, from the point of view of dependent origination. So we need to discuss the issue, and I don't know the answer that how you can explain these kind of constants. Say, for example, there are fundamental constants of nature exist, like speed of light, which has definite numerical value, 3 into 10 to the power 10 centimeter per second, or Planck constant, which is definite numerical value, or gravitational constants. So why they have a definite numerical value which can be experimentally verified? How it is compatible with Buddhist conceptual framework? Or if you go to the more primitive stage, like in all the, I think, Indian philosophy, including Buddhist one, people say subtle matter and gross matter. So what is the subtleness of the matter? Many people say, well, we go to the further and further down, from top to down, top to bottom, like ordinary object to electrons, protons, etc. They are subtle. But what is the subtle object? According to scientific point of view, we say that the subtle object, subtle matter, are those matter which cannot be perceived by ordinary senses. You need instrumentations. And according to Indian philosophy, like Nyaya school, they say that subtle matters are those matters which you need, apart from your sensory input, you need kind of experience. But we scientists don't understand exactly what this experience means. So, if we take the definition of the subtle matter as sensory input plus instrumentation, then a bacteria, which we cannot see through our naked eyes, a galaxy, a neutron star, a black hole, those are subtle matters, like electrons, protons, etc. And we need to discuss exactly what do we mean subtlety of matter and gross matter. So there are a lot of issues, and moreover, I just end up with a minute that since the inception of quantum theory, people try to discuss what is the role of observer or sight or mind. But again, the question comes up, what is mind? There is a man who usually sits next to my office in USA. He used to ask me, he comes once in a week, he used to ask me, he should tell me, where is my mind? And his name is Professor Carl Fibra, that famous brain researcher who proposed holographic theory of brain. So we scientists, we start from a lab, we start from some physical object, like, billions of neurons in the brain. So we try to understand this, what is mind, from the perspective of neuronal dynamics. So we have invited eminent neuroscientists and medical persons to understand exactly whether we can understand mind or sight in terms of neuronal dynamics, or you need new paradigm. So thank you all again, and we will discuss all these questions in this 2-day meeting. Thank you.
Thank you, Professor Cecil. Now may I request Professor N. Mukunda ji to give the keynote address from a quantum physics perspective.
Remarks. Yeah. So we will go to the next page. What is this one? Yeah. Thank you. This one. Okay. Good morning. My sincere thanks to the director of Tibet House, Geshe Damdul, and to Professor C.C. Roy, the prime mover behind this conference, for inviting me to participate and to speak briefly in this inaugural session on quantum physics. Many similar meetings have been held in the past few years. So by now, I think many Buddhist scholars are quite familiar with the basic features of quantum physics and quantum mechanics. So I will limit myself to a few important features of the subject which I feel should be kept in mind in discussions like this conference. These features refer not so much to the details of the subject of quantum mechanics, but to its overall structure. At the start of modern science, about 400 years ago, essentially through the work of Galileo Galilei, two fundamental new ideas were introduced. One was the idea of controlled experiments. The second idea was the use of mathematics to express the results of experiments and then analyze them. It was through their combination, I repeat, controlled experiments and the use of mathematics, that one could understand how nature works and discover her laws. Let me understand the laws of this computer. Galileo also made a very important statement. We must measure what can be measured and make measurable what cannot be measured. This is a very important, it's a very profound statement. One must be quantitative in trying to understand nature. This led to the idea that every important property of any physical system has a definite numerical value at each time, which we can measure. And then we study how these values change in the course of time. The world is out there. We can observe and measure every property of it to any desired accuracy. Later on, we learned that if we are not able to make measurements exactly, but only approximately, we have to bring in the ideas of probability theory. Thus, the role of probability in the classical period was not a primary role, but it was secondary, related to how well we can make measurements. There was thus what I would call a strong emphasis on a number-based approach to the description of natural phenomena. Over the next 300 years or so, the structure of classical physics was developed, with many new mathematical concepts being created as new physical phenomena were discovered. So the subjects of mechanics, optics, electromagnetism, thermodynamics, radiation phenomena, each of these grew enormously. At the end, it was clear the world contains two kinds of entities, particles and waves. And they have characteristically different natures and mathematical descriptions. In hindsight, the whole subject of classical physics acquired what we may call a mechanical flavor. Indeed, Lord Kelvin, one of the last great figures of the classical era, said at the end of the 19th century, to understand something in physics means to make a mechanical model of it. Over the earlier part of the 20th century, roughly 100 years ago, the most important advances in physics were the two theories of relativity in 1905 and 1915, and the quantum revolution, which started in 1900 and culminated in the creation of quantum mechanics over a very short 2-year period of time, 1925 to 1927. Both these developments in physics, relativity on the one hand, quantum theory on the other, they involve deep but different kinds of mathematical ideas. Both have had profound impacts on our perception and understanding of the physical world, but from the philosophical point of view, it seems that the impact of quantum mechanics has been somewhat greater. After all, as far as I am aware, Professor Roy, we have not had conferences on Buddhist philosophy and black holes so far, or Buddhist philosophy and gravitational waves. They have not had. So let me go back to the quantum theory. Quantum physics grew out of unexpected experimental findings which could not be understood classically. They required revolutionary new conceptual advances. What were the phenomena involved? The nature of radiation, the structure of the atom, the stability of matter, the ultimate nature of light. All of these were involved in the growth of quantum ideas and quantum physics. So let me now present to you a few features of quantum mechanics which are strikingly different from the earlier classical ideas. One, the physical properties of a system cannot be thought of as just numbers, always having definite values. They are new mathematical quantities which in general do not commute. What does that mean? In general, a physical property A and a physical property B are of such a nature in the mathematical treatment that the product AB can be defined, the product BA can be defined, but in general they are not the same. Position and momentum are an example. Second feature, when a physical property is experimentally measured, the result will be a number. But this cannot be calculated or predicted in advance with certainty. All that we are able to do is to calculate probabilities for different results when the experiment is done. So in this way, probability plays a primary role in quantum mechanics, which it did not play in the classical physical theories. The third property is non-commuting quantities, things which have the property AB not equal to BA, they are said to be not compatible. What does that mean from the measurement point of view? They cannot be simultaneously measured. Position and momentum is the most important example. So if position of a particle is precisely known, at that same time the momentum cannot be known, and vice versa. So, remembering what Galileo Galilei had said 400 years ago, measure what can be measured and make measurable what cannot be measured, the emphasis was on number, on value. Here is the new point of view. This is from Hermann Weyl, writing in the year 1928. The continuum of real numbers has retained its prerogative in physics for the expression of physical measurements. But the essence of the new quantum mechanics is the fact that there is associated with each physical system a set of quantities, a non-commutative algebra, the elements of which are the physical quantities themselves. In my experience, even physicists who have understood quantum mechanics very well and been exposed to it for a long time may not appreciate this fact, the switch, the movement from number to something different from number in the description of nature. This is very, very profound. So going back to my list of features of quantum physics, Particles and waves in quantum physics are profoundly different from their classical counterparts. What we call a particle in quantum theory has wave-like features. And what we have a wave in quantum theory has particle-like features. So there is a tremendous change in the physical meaning and the properties of both entities. In a sense, what seemed like a dichotomy classically has got unified in quantum theory to one thing. The states of a quantum system form a complex linear space. They obey what is called a superposition principle. There is a way in which you can take the description of one quantum state, the description of another quantum state, and add the two. The result will be yet another, a third quantum state. This is something which has no classical analog or meaning. There is a replacement in quantum mechanics for the familiar Newtonian classical equations of motion, which are studied in the CBSE. In quantum mechanics, it is replaced by what is called the Schrödinger wave equation. But it has a very different quality to it. It cannot be checked or tested directly. You cannot observe a quantum system and see from instant to instant, is the Schrödinger equation being obeyed? In the sense in which you can imagine Newton's equations of motion being checked moment to moment. The only way one can infer that the Schrödinger equation is correct is to check its predictions with measurement. It predicts probabilities, those can be measured, and if they agree, you say, indirectly we see that the Schrödinger equation is working. I think from these points one can see how subtle quantum mechanics is. It remains a constant wonder to many of us in the physics fraternity how the founders of the subject were able to discover its structure and create a coherent theory. Philosophers or not, as physicists with feeling, this is some incredibly wonderful achievement within the realm of physics. The key mathematical features of quantum mechanics, I repeat, are two. Non-commutativity, which is properties are not numbers. Second, the superposition law, a new way to combine states of a physical system which has no place in the classical way of thinking. So I feel that trying to understand quantum mechanics without acknowledging its deep mathematical structure is, in my view, futile. No wonder Dirac said in 1930, when he wrote the first book, The Principles of Quantum Mechanics, he said, the fundamental laws of nature control a substratum of which we cannot form a mental picture without introducing irrelevancies. So Dirac's main message was, it is not useful, you will fail if you want to make a mental picture of quantum phenomena. Follow the mathematical structure, calculate, and then compare with experiments. So out of the attempts to understand this theory came many consequences, some of which have been mentioned. The uncertainty principle, the duality of particles and waves, which actually came before quantum mechanics, and also an elaborate theory of the measurement process. I will be saying a little bit about it tomorrow. All this is essentially part of what is called the traditional Copenhagen interpretation of quantum mechanics. The approach to classical physics, which is, after all, a limiting form of quantum mechanics, is another major aspect that has to be understood. Many leading physicists, about 100 years ago, at that time, Einstein, Louis de Broglie, Erwin Schrödinger, and others, they were profoundly unhappy. They were profoundly unhappy with this state of affairs. There was a suggestion that by suitably augmenting quantum mechanics, one could return to the more comforting classical view. The work of the last 50 years or so has shown that this is not possible. It is in this effort that ideas of non-locality, entanglement, contextuality, and so on appear. Many of these will be brought up in the various sessions of this conference. Of course, the successes of quantum mechanics are well known, so I do not go into them. I will only conclude by saying, from the point of view of this conference, we have to keep, in my view, these 3 points in mind. There were several schools of ancient philosophy, not always agreeing with one another on all aspects. So there were differences which were allowed. Secondly, the contact with the essential mathematical structure of quantum mechanics should be maintained. You should avoid purely qualitative arguments, but this is, of course, a very difficult problem. And lastly, among professional physicists, at least in the West and particularly in the USA, interest in such efforts seems limited. Nevertheless, if we feel these explorations have true value, we must try. So let us hope we all learn from one another in this meeting. Thank you again for giving me an opportunity to present these ideas.
Thank you, Professor Mukundaji. Now may I request our Honorable Chief Guest, Dr. Goswami Ji, to address the gathering.
So, Director of Tibet House, Venerable Dhambu, Professor Mukunda, Professor Sishirai, the all the distinguished guests here. I think Professor Sishirai was trying to say whether his presence here was justified or not. That sounds to be very justified, but I'm very, very doubtful about mine. So, after all that has been said, I think there is very little I can add to these discussions, but therefore I would just like to share a few thoughts with you regarding the conference and its overall objective. I think first thing, I feel that when we are talking about interfacing or connecting Buddhism with quantum physics and brain functions or neurosciences, it is probably better that we present Buddhism as a knowledge system rather than as a philosophy. As His Holiness Dalai Lama has said quite some time back, that quantum physics and Buddhism are ready to, or have made handshake because they have come quite close. So I think that becomes more effective if this entire thing is put in perspective, that Buddhism is also a knowledge framework, a conceptual framework, which is what I think probably Professor Mukunda was also trying to say. I don't say that Buddhism needs to be or can be put immediately in mathematical formalism, but the precision and accuracy need to be brought in. It's not uncommon to see that two persons talking about the same, some quite different concepts using the same terminologies. And when it comes to words like consciousness and mind and maybe matter, we talk about gross matter and subtle matter, but probably we haven't defined what matter is. That was even the case even in case of probably when people talked about wave-particle duality. What exactly is a particle in terms of definition, and what exactly is a wave in terms of definition? Particle is probably one that can transfer momentum. Wave is probably one that can interfere. But to an extent possible, that definition becomes necessary. I think similarly, I would also feel that one reason why what Professor Mukunda was saying, that limited interest in the West, I must say that science takes a minimal view. It admits a theory or a new thought only when it must. Not I mean, one can have conferences, but otherwise they will not do it unless it is they have to include it. You have the concept of Occam's razor also, the shape of everything that is not necessary, if only one is bare minimum that is necessary. And that will be more so, therefore, if we take a more proactive rather than reactive approach. Our approach, I'm not talking about only Buddhism, I'm talking about Vedanta, I'm talking about various other philosophies, has been that, oh, this is there, but we also have this. We have also similar thing. It's more about, as if almost looking for acceptance or agreement and not looking for a contribution. A contribution comes on the other hand when there is a conceptual vacuum or a need to fill up something, and we provide that. And I do believe personally that in Buddhism, in Vedanta, and in other schools, there are concepts and constructs that can do that job, that are eminently important. In Buddhism, for example, we have the concepts of sunyata and utpat. They must be considered together, if I understand, or at least I believe. Right? So sunyata, if you take the counterpart as vacuum, the utpat must be considered as the fluctuations. And that gives rise to, utpat, if you remember, these are all Sanskrit words, and we need to go back to the roots. So basically, utpat is a product. It's a substance, it's a support by the sunyata. So I think I would like to propose that we take a more proactive approach and come up with something that contributes to the ongoing search, ongoing quest for knowledge. Because after all, it is finally the human repository of knowledge. In fact, I like to think of us as migratory birds in the knowledge stream or in a knowledge space. And we are all trying to go to the same, home, so to speak, which we may call nirvana, or which we may call moksha, or whatever, but it is finally we are going towards strange attractors, following very, very convoluted path probably, but goal is the same. And in all of these, we can think of this as a knowledge front, as a wave front, and if you remember the Huygens principle, every point in the primary wavelet becomes a source of the secondary wave fronts. So, I believe that such events are very necessary. If you also remember that whether it is Buddhism or Vedanta or such schools, they did not evolve in very quickly, not like a burst. Like Professor Mukuda said, quantum physics developed in a very short period of time, but it's still evolving. So are these other schools. The Upanishads developed over several centuries, and it is still a living literature. And so is Buddhism. It's still a living literature, still a living knowledge system. So can we think of concepts or areas where we can proactively contribute? For example, the whole problem of the criterion of reality, which basically the substance of EPR paper, and what can we contribute to that to resolve that problem? So a stronger focus, along with a broader canvas like this conference, will probably be also helpful. So as I said, I cannot hope to really contribute intellectually very much to such, August gathering. So I just wanted to share a few of my thoughts. So thank you very much again for inviting me.
Thank you, sir. To conclude the inaugural session, I would like to thank our Honorable Chief Guest for taking out time for us. And I also would like to thank Professor C.C. Roy and Venerable Geshe Toshi Tamdila for bringing quantum physicists and neuroscientists and Buddhist scholars all in one gathering. Thank you all, and now we'll break for 15 minutes and we'll be back at 11:20 a.m.